Hello, take it you can all hear me. I'm Ian Merrington from Sky Broadcasting. I'm an ex-Oracle DBA. I'm now a Couchbase DBA, although somehow my official job title is somehow a Persistence engineer, which I don't like at all, but that's the way it is now. They're trying to get rid of DBAs. So I'm here to talk about our journey with Couchbase to provide a high-performant, highly available platform for the Sky online streaming product. Hopefully I can show you just how flexible Couchbase is and how you can simplify your stack whilst providing the performance required to cope with the kind of peaky loads that we get on our platform. And the problem with talking last at a conference is that when I wrote this, I didn't really know what Couchbase we're going to be announcing at the conference. And there's a couple of challenges that we've had to overcome that look like they can be easily solved with the latest version of Couchbase that you're releasing. So I'd like to think that if the analytic functionality that you just announced was available earlier, then this presentation would be completely different and we'd end up with a completely different architecture. But I'm certainly looking forward to going home and giving it a go. So when I'm doing these talks in Europe, this is the one slide I don't normally have to bother with. A quick straw poll in the bar last night, though, suggested that despite being one of the biggest brands in Europe, we're not particularly well known in the US. So the conversation usually went, you work at Sky? Who are they? It's a big TV company. No, never heard of you. So Sky Sports, we've got all the Premier League and major sporting stuff in Europe? Nah. What about if you're in a hotel maybe in Europe, there'd be a Sky News channel? Oh yeah, I've seen that, yeah. So we're not just Sky News, we're a big TV company. We're kind of a big deal in Europe. We're Europe's leading entertainment content business, which is the corporate way of saying we sell TV shows to the masses. We're primarily known for our satellite TV product, but we've become much more than that over the years, constantly investing in technology and giving a much better customer experience. Our TV shows are delivered to over 50 million households, not just through our satellite technology, but also through other cable TV providers and streaming directly across the internet. We've got the #1 pay channel portfolio in Europe, providing sports, movies, and our own original content. Historically, we've used our large sporting portfolio to drive subscriptions. And we offer more Premiership football in the UK than anyone else. We're home to the NFL, the Ryder Cup, cricket, F1. But we don't want to be known solely for our sports stuff. And we're investing heavily in content. And so we're able to supply the biggest TV shows from the US, including Game of Thrones, Walking Dead, Westworld, and many more. We've got our own studios, our own production companies, so we can produce our own content, and we often partner with the US companies to co-produce shows. And as well as that, we've got a 4 times Tour de France winning cycling team, which I'm not sure exactly how it fits in with the business model, but it's something to support. So since the turn of the century, we've been innovating and improving our ability to deliver the content to the consumer. And from about 2005, we began offering a streaming platform that allowed our customers to consume the content from their laptops and mobile phones. In 2010, these products merged into the Sky Go application, so you got the same experience on your mobile as you would on your laptop. And in 2011, we saw the launch of Now TV, which is a streaming-only service that uses the Sky Go platform, and it allows our content to be streamed by those who don't want to sign up for a subscription or anything like that. So kind of more of a Netflix kind of model. And Now TV offers various different packages. So you can get your movies, your entertainment. But you can also buy like a monthly pass to watch sport for, say, like the Ryder Cup. Or maybe you can even just buy a day one if you just wanted to watch one particular football match. And since Now TV, the product is expanded and it's available on most smart TVs, Roku boxes, Xboxes, PlayStations. We're available everywhere. And the platform is called the OTT Platform, which stands for over the top. And I don't really know why it's called over the top. but I didn't make that decision. And we've recently transformed the platform. So we're embracing the use of distributed databases, multi-data center deployments to allow us to cope with the increasing demand and the spiky traffic patterns that we see on our platform. We support multiple Sky applications. We've got Sky Q, which is the new set-top box that is like a hybrid satellite TV and streaming box. We've got the Sky Go application, which we've already mentioned. Sky Kids, which is like a cut-down content, just aimed squarely at the children. Sky Store, which allows you to not only purchase programs to download, but you also get the hard copy on DVD posted to you as well. And then we've got Now TV as well. And the OTT platform is kind of unique in a way. We don't only focus on one type of delivery method. We have on-demand or VOD traffic. We have linear, which is the live TV kind of traffic. We've got DRM to protect the content. We've got concurrency limits. We've got the ability to download so that you can save it to watch on the train on your way to work or something like that. So we've got a pretty complete platform that compares favorably with our competitors. It supports 80 devices. There's 20 TV channels, 200 TV channels across the EU. We've had 750,000 concurrent users in the UK, over 1 billion downloads. So there's a lot of stuff, and you need a platform that can support it. Now TV is increasing. It doubled its concurrencies from 2014. It's doubled it again. There's over 500 million streams delivered last year. And so Now TV is driving the growth on the platform. So we're conscious that there are cord cutters out there, and we want to make sure we're still part of that market. Handling live and on-demand traffic presents unique challenges. The daily kind of load pattern is as you can see on the top diagram. It's fairly regular, builds up in the afternoon, drops off overnight. The weekend's slightly different. You get a bit of a higher thing, but it's a consistent model. It's easy to scale for. We kind of know what we're doing. So that's the kind of the on-demand stuff. But the linear stuff is a different kettle of fish. It depends what's going on. Usually it's sport that causes the high demands in traffic. So a big Premier League match or a really exciting cricket game. They do happen, honest. And it's been kind of our bread and butter. We know what we're doing. We've been doing this for years. We see much more traffic on a game between like the top Premier League teams. If we know they're playing, we know we've got high demand. If we've got a game in the evening, that generates much more demand than during the weekends, because I think that the family might be sat around watching TV on the main TV, and then you might be wanting to watch the game in the corner on your phone. Pretending to spend time with the family, but really keeping an eye on the game. So we've been doing this right. We know what we're doing. We've got a pre-production environment that mirrors prod. We run the load tests. We do all the right things, and we were good. It was all good. And then a certain fantasy TV drama came down, and it changed all the rules and forced us to throw some of these models in the bin and start again. So that was, Game of Thrones. And it was the bane of our life for a period. So I'm primarily here to talk about the actual identity platform, which is the gateway to this streaming platform. It provides full sign-in, sign-up functionality across the whole of Sky's online estate. So it's not actually just for the streaming platform. It also the customer management apps, the remote recording, and we also partner with Yahoo to provide email access. So that all goes through the identity platform. But by far and away, our highest use is for access to the streaming content. We've got multiple different methods to sign in, so we can support every type of device, browsers, mobiles, Xboxes, PlayStations, you name it, you can use it. We provide traffic analysis for security and fraud detection. We feed into the business intelligence team. And it's a fully scalable configuration, fully scalable. It's multi-data center. At the moment, it's only active-passive, but we should be going active-active in the new year. And we use, obviously, the reason why we're here is we use Couchbase to store all this data. The type of data that we've got, it's pretty much what you'd expect for an identity platform. You've got the sessions, very small documents, high volume read and write. We use the TTL functionality to expire them when they're done. The profile data, so your username, your entitlements, what you can actually access. Credentials data, obviously this is encrypted. We don't want to be like some people and lose that information. We capture the event data, so we've got last login that's used for our dormancy, we've got a process that clears down old accounts that haven't been used for a long time. And we've got these things that we call index documents that are basically, they're small pointers that point back to the main profile. So we were using views to do non-key lookups, but we migrated to using the index documents to provide a more consistent performance. For key lookups such as username and email address, we just created a document where the key contains the value of the, so you'd end up with a document like username underscore I love Sky. And the document contents then a link to the actual profile doc. So instead of doing one lookup, you do two lookups, but because Couchbase was so fast, there's barely a hit on the application. And doing it this way allows us to kind of enforce some uniqueness checks across the data. So you can't have one profile have the same, or you can't have two profiles having the same email address. It did increase our document count by up to 5 times. So we went from 30 million documents to lots, 30 times 5, yeah, hundreds of millions. And we needed to make sure, yeah, our cluster had to be sized to handle this. But there's some additional maintenance involved in having these. You need to make sure that you've got a consistent, because you've almost gone to a relational kind of model, and I don't like that. But we did it for performance. Now you've got Nickel that's come along. Hopefully we can throw all that away, go back to having a smaller document count, and use the functionality within Nickel to do these lookups. But that's something for another day. So our kind of traffic load that we get, our peak traffic, as I said earlier, that it's the football matches. And you get that very distinct two-peak kind of ramp up for a football match. So you get the big peak. There's hundreds of thousands of users logging in over about a 20-minute period before the game. And then you get a second spike at half-time. And you get a spike maybe after each goal or controversial moment where people are picking, they hear about it, pick up their phone, and log in and try and catch the goal as it happens. Or just after the replay, otherwise that would be impressive. But then along came Game of Thrones. And season 4, the first episode in particular, there was a massive amount of unexpected demand. We had some downstream services fail that caused the users to go back into a sign-up loop, which then added more load to us, and it brought us down. And this outage was embarrassing for everyone involved, really. People who like Game of Thrones are on Twitter a lot, and you could follow the problems just reading Twitter. So it was a key driver into the replatforming of a lot of the downstream services to become NoSQL like we are. So why were we caught out? We'd never seen this kind of demand before. And if you look at the graph there, that shows the viewing figures for Game of Thrones. There is a bit of a jump between season 3 and season 4. But it's not a massive increase, and it shouldn't have caused us a problem. But what we hadn't fully taken into account was that Now TV were now offering an entertainment pass, and it had just come online just before it. And Game of Thrones is the most pirated TV show in the world. So lots of viewers are used to watching it on their laptops and phones. And because Now TV had this entertainment pass that allowed you to, for a fairly small amount of money, sign up temporarily just to catch the 10 episodes. A load of people had got these passes and were using it for Game of Thrones, and it totally caught us by surprise. And the traffic is a totally different spike as well. We were used to a 20-minute ramp up, but unlike sports, people don't tend to log into a TV show 20 minutes beforehand to catch the build-up, because that's another TV show. They just don't do it. And they don't log in after, like people don't tend to log in 5 or 10 minutes into a show either, because you've already missed, especially with Game of Thrones, you've already missed about 10 murders. And so yeah, it was very different. A big spike, one single spike, and this was now the new norm. So the Game of Thrones testing, it became like every week we need to test for Game of Thrones, test for this. So the identity platform could actually handle the load. Couchbase was brilliant. It was the downstream teams that were causing us the problems. And Game of Thrones is still the one TV show that drives the most traffic. I don't know whether it's just more popular with people that watch the show on their laptops. But we don't see it, even though other popular shows like Walking Dead, they're not anywhere near as high demand as Game of Thrones. And you've got to love the TV schedulers, because they schedule Monday night Premier League football alongside Game of Thrones. So the second half spike that we get, you also get the Game of Thrones spike. And our highest ever load that we've ever had was during Game of Thrones last year, when Tottenham and Chelsea were playing in the run-up to the end of the Football League. It kind of was the game that decided the championship. So. But we passed with flying colours, so it's all good now. So how do we handle all these demands? This is how it looked when I joined. So you can see, first up, there's no Couchbase. I joined at a pretty interesting time for the team. They were replacing a legacy application that used a combination of Oracle, LDAP, and OpenAM, and we're moving to a NoSQL-based solution. They'd already implemented BigCouch, which is a branch of CouchDB that offered sharded distribution. And I was being interviewed by the outgoing DBA and the architect. And instead of the usual kind of interview questions, they just argued for about half the interview. RDBMS is much better, NoSQL's the way of the future. And ever the diplomat, I thought I should probably agree with the architect, because he would be the one employing me. And so, yeah, like this NoSQL looked good. And he actually was right as well. Like, the profile store is almost a textbook kind of product for a NoSQL. It's flat data. It's very simple to model. So he was right, and I'm thankful for it, because it got me into NoSQL and away from Oracle, and it's been liberating. It was about 3.5 years ago that I was actually hired. I was a contractor. I was hired on a 3 months contract. They said, just come in, turn Oracle off, and all will be good. I did finally turn Oracle off about 4 months ago. It took me 3 years, but I did it. And I don't want people to think I was the Oracle guy, kind of dragging my feet, wanting to keep it in. It was a horrendous schema to maintain. It was unscalable. It was all the usual reasons why you want to move off Oracle and move into maybe NoSQL. I could probably have filled this talk with just hours of me moaning about how bad it was, but the devs can talk at great length as well. The challenge is trying to keep a NoSQL and RDBMS database in sync. Their transaction manager was the work of legends. I never understood it. But the biggest problem was the business loved Oracle for one reason and one reason only, and that was for their kind of business-type queries. But then why did we switch to Couchbase? Well, Big Couch, we were happy with it. The performance was good. It wasn't amazing, but it was good. The functionality was all there. But then we had a requirement that we needed to move data centers. Now, this was a problem because Big Couch didn't really have a replication method. And we also had some very aggressive timescales as well. So devs being devs, they came to the conclusion that they know Big Couch, so they know Couch. They know Memcache, so really they know Couchbase. And so, but they picked Couchbase. I was still to one side as the Oracle guy, but when I started seeing Couchbase in action and the things I could offer, I sort of picked it up and became a Couchbase DBA. But the big problem we had was aggressive timescales, and we didn't have, the reason we needed to move data centers was because we were running out of capacity in that data center. There was no space to build a new cluster or anything. We had to cram it all onto the existing ESX hosts. And a big shout out to the Manchester support team for keeping us going during that period. But we got up and running, we got the replication running, we got into the new data center. We were able to scale out there, scale up there as well. There was more capacity. So it was great. XDCR worked flawlessly. It got the data there. We actually used Golden Gate to get the Oracle data. We had to write a custom script to get the OpenDJ data, and we just lost all the session data in the transfer. And wouldn't it be great if there was a way to leverage XDCR for all of these data stores? And so we just started removing them and migrating everything into Couchbase. So first off, we got rid of OpenDJ. This was the most important data to migrate. It's had huge implications for our DR strategy because the current DR plan required restoring a backup in the DR site, so that's very slow. So by migrating that to Couchbase, we dropped the recovery time from hours down to minutes. And although it increased traffic on the cluster by about 20%, it reduced the sign-in response time by 50%. And so not only were we more resilient, but we were faster, and we had an uplift in capacity. So it was a good win. So we then moved on to the session store. We had to scale out the cluster by about 60% to allow for the new kind of load profile. Historically, the profile store was about 90% read traffic, 10% write traffic. Most of the time, you're just serving up the profiles and you're not making modifications to them. The session store was completely different. So each time a user logs in, you have to create the session. There's various different mechanisms for refreshing the session, extending it, and they all require writes. Logging out, you have to do deletes. And so suddenly, a cluster that had been built primarily to serve data was now writing data as well. And yeah, we scaled it out to cope with it, and it again was flawless. There was response times were comparable with Memcache, but now we had the ability to persist those to disk and use XDCR to get all the session data across into our DR site as well. So during a switch, our customers wouldn't have to sign in again. So this really reduced the impact if we ever had to switch to DR, and has kind of opened the way to having an active-active solution. But where next? There was still Oracle, and it was still a sticking point with the business. We want to perform our ad hoc queries. We've got Splunk, which is great at telling us when something has happened, how many times something's happened. It's ingesting all the application logs, but it can't tell you how many profiles have got. How many profiles beginning with has a name that begins with Bob or something like that. And there was enough of these queries that came through the business that we needed something to satisfy that demand before we could get rid of Oracle. And we also had this active-active requirement that was coming. And I as much as I've used Oracle over my career, the thought of an active-active data guard Oracle cluster thing was the sort of a nightmare vision. So we had to do something about it. We weren't sure what to do, and then Couchbase came up with the goods. Nickel gets released, and we're all good. We really wanted to keep our queries away from the main data store, so we built a smaller offline database cluster. XDCR makes it trivial to set up and push your data out to this separate query cluster. This cluster became known as the JCB, or Justin's Couchbase, after the product owner who generates most of the requests. So it annoys the hell out of him. So it was worth doing it just for that. The ability to run queries against a database proved invaluable recently. I think you've probably all heard of the Yahoo data breach that they had. So we get the call, because we use Yahoo as our email provider for our customers, we have to sync our passwords with them. So their breach was our breach kind of thing. We had to do some analysis, and it was 6 o'clock on a Friday night. The business intelligence team had gone home. We've got the business execs, we've got the security team just yelling at us, like, we need to know which customers are affected, who they are, when did they last change their password, when did they do this, blah, blah. And thankfully, we had Nickel, we had the Couchbase, the JCB, and we were able to provide these queries straight away. And for that, the team got much kudos, much thanks from within the business, and it was all down to Nickel being the right product at the right time, and so really saved our bacon. The migration from Oracle presented some, I say interesting challenges. I thought it was an interesting challenge. There was a table of over 35 million rows that contained data that only existed in Oracle. It was event-type data, and it was used to determine if a user profile could be deleted. So if we haven't used the profile for a certain amount of time, and there's some various other rules around it, but if we haven't used it, we remove it. And we have a history amongst our team of our migration scripts maybe taking a little longer to develop than they should, and maybe perhaps not being as fast as they should. And I didn't want this to go the same way. And the Couchbase blog is brilliant. It's well worth keeping an eye on. And it just so happened that I think Nick Raboy had just written a blog post about how to use Apache Spark to just push data into Couchbase, pull it out. And I was off sick, and I thought, well, let's have a look at this thing. And it was a really simple, it's just the code to the left of the screen, just those few lines just are able to push data into Couchbase at a phenomenal rate. I was able to load 500,000 records, well, no, 1 million records in a matter of minutes. And this was on my battered old MacBook Air. So I get to walk into the office on Monday. Here you go, guys. This is how we can do the migration. It can read from Oracle, push into Couchbase. So, yeah, it kind of allowed us to get that data in quickly. So the Spark connector is a fantastic tool for all the Spark analytics and stuff, but it's also a fairly useful tool just for simple data manipulation that you've got. So I've got a quick demo of it. Maybe, if my laptop will play. Come on. That looks better. Even better. So, as I said, it was just that simple bit of code. I've got a Couchbase cluster up and running. And this is just running on my laptop. None of that fancy Amazon stuff for me. I haven't got a network connection, so this I'll have to do. But what's good about the Spark connector is it simply allows you to just you run it like that. This isn't actually reading it from it's just errors all over the place. What was the problem there? Expected host name. Tell you what, let's maybe not do the demo. Yeah. But that's weird. I'll give up. It's another blue line that you've seen 1,000 times at this conference, but it's really good because you've got the GUI as well that shows you how well it's doing, how far you've got in the process and everything, and it's really simple. It's really simple when it works. So back to the slides. find my mouse pointer. So this is our current implementation then. You've got the SkyID application. We've got the one Couchbase cluster. We've got the JCB. But from seeing all the talks about the analytics and stuff, I'm hoping that in the near future, we could maybe just combine it all back into one cluster again, have the analytics running next to it. I think that'd be a fantastic solution. So as I said, I can't wait to see that and have a go. The future, we're expanding into Europe. We've now got a duplicate of all this, which we're using for the international stack. Again, the simplicity of XDCR and everything has allowed us to migrate some of the data that we needed to migrate quickly and simply between the various stacks. Our security team's using Couchbase for some application log analysis. We've got a persona store that we're building that kind of extends the profile information so you can have separate personas or attached to one logging. And we're growing the Couchbase community within Sky. So we love Sky. We love Couchbase at Sky. It's been so reliable for us. It's sort of consistent. It hasn't gone down. We haven't had a single production outage in 3 years since we've been on Couchbase that wasn't due to maybe somebody turning off one of the servers or something like that. Couchbase itself has been totally stable, and it's a perfect use case for a profile store. So if anyone's got any questions, feel free.
How big your cluster? Like biggest cluster? How many nodes?
It's not that big. It's 10 nodes. We've got 10 nodes in one data center, 10 nodes in the other one. So the question was how big is the Couchbase cluster? It can handle tens of thousands of logins a second. And we've never really hit the maximum capacity of the cluster. It's sized. In prod, we're sized about for 3 times our expected demand after we got burnt with the Game of Thrones originally. So, yeah, it's good, and it's handled the load perfectly.
What version of Couchbase are you running on?
So
do you use views? I noticed you moved away from them in one of the early slides.
Yeah, so we were using views. The performance of the views was just not as consistent as the key value stuff, and because we integrate with so many other teams, having any kind of inconsistency in our performance could have knock-on effects on their performance. And so that's why we stopped using the views for any of the key user journeys, and used these index documents as a separate way of looking up. But we do still have a couple, like we use one that just for information purposes, like how many documents we've got, what types of document. The things that views are good for, the aggregations and stuff like that. We stopped using them for the lookups because they just weren't quite so performant. And you said, what version are we on with? The main cluster's on 3.13. Looking to upgrade before the end of February, because that's the end of life. So we've just started testing 4.51 for that in the staging environments last week. It looks to perform as well as 3.11 was. I know some people have got an uplift in performance. We haven't done enough testing to prove that yet. We've only run some baselines. The JCB is on 4.50, looking to upgrade to 4.51 in the next week or so. We did see some big improvements over 4.1, I think we had before. We went from 4.1 to 4.5 about 2 months ago, I think. And that is a much more solid. There was just some improvements in the nickel side of things that we really benefited from.
I'm just curious, what kind of CDN architecture do you have?
What kind of what?
CDN, Content Delivery Architecture.
I'm afraid I'm the wrong person to ask.
I'm just curious.
Yeah, I've never got involved in that side of thing.
You have that?
Yeah.
Do
you have any other questions?
What's your application written in?
It's Java. Although there are bits now that are being written in Scala that the devs are just beginning to get there. They wanted to use some of the non-blocking stuff in Scala with the, because we've only recently gone from the 1.4 version of the Java client to the 2.1, I think it is. And so that there were some benefits there that we're not making full use of at the moment because it's quite an old application now. It's 3 years old, so there's bits of it that could do with rewriting to use non-blocking and get the performance gains there.
You mentioned that that you're running out of capacity in your data center. Do you have any views on moving any of this to the cloud, or is that kind of in the future?
So Sky have a presence in Amazon. There was a push a few years ago to push everything into Amazon, and now there's a big push to push everything back into our own data centers again because they perceive that there's some cost savings there. Seeing how long it's taken to move it back in, I don't know whether those cost savings have got eaten up already. But I think certainly for the identity platform, there's no plans at all to move it anywhere other than into our own on-premise VMware cloud.
Why are you moving back to on-premises from AWS?
So why are we moving back from AWS? It's a cost. It's perceived somewhere that it costs more. I haven't done the maths myself, but that's the way that it's going with Sky at least.
What's your hardware config and how much percentage resides of your data resides on RAM?
So how much percentage of our data is?
So you moved Memcache also into CouchDB, so I'm hoping you're putting some data in memory. So
yes.
Are you using 100% in memory or percentage of it?
No, so for the session store, the Memcache stuff, then yes, that probably is all in memory. That definitely is all in memory. The profile data, our working set is probably about 30% of the data. The nodes have all got 64 gig of RAM, and that's divided into the session bucket, the profile bucket, and then there's another bucket called ephemeral for data that doesn't really stay around for very long. And it's just the profile data that we're using. It's smaller than the actual data set, but we haven't really seen any issues running that way. It's sized so that our working set fits in memory, and that was the important part.
Any other questions?
Cool.